All right, good morning. So you guys haven't met me yet. My name's Don Burks. I'm the tech lead for a company called Sphere, based here in Vancouver. A little bit of background on me. I've been a web dev for over 20 years. I used to work here, in fact. I was the head instructor for 5 years. And I've worked for a few other interesting companies, worked for Microsoft. I was the senior dev for MetroLyrics.com for a couple years. I've done about 12 startups. None of them made any money, don't worry. And that wasn't my fault. In terms of other background, I actually started off with a degree in music. I'm entirely self-taught as a programmer. I've never taken a programming class or a computer class of any sort, and I've still managed to have a 20-year career. There weren't boot camps when I started programming. Sadly, there wasn't Google when I started programming. So it is entirely possible, and you've got a huge leg up. Quirky fact about me, you'll learn many, but the one that I like to give is I'm kind of interested and passionate about the idea of biohacking, where you merge technology and flesh. So I have an RFID NFC chip implanted in my hand. And so if you have NFC on your phone, you can actually just touch your phone to my hand and get my contact details. And I want to reprogram it so that I can swipe to get in the door. That's my next project in my spare time next week. So, all that being said, let's talk about objects. When I'm going to be going in and going through things, I tend to do my lectures where I start off with a bit of philosophy, a bit of context, a little bit of history if it applies, and then I'll get into real code. And I'll give you the directive now that, especially in this early point of the boot camp and as you get deeper in for the next 11 and a half weeks of your life, during lecture, don't worry about having to follow along with the typing. Focus way more on understanding what's going on that screen rather than what's on your own, because if you're trying to keep up with the typing, you will get lost, guaranteed. Besides, all the notes are going to come out to you anyway, all the code's going to come out to you, and you will get the finished version with, hopefully, no typos in it. So, that being said, if we're going to talk about objects, we have to ask the question, what is an object? Who wants to be brave and bold first thing in the morning and tell me what an object is? Go for it. It is a data structure which allows you to store data inside. You are not wrong. Let's go more fundamental than that. Give me a little bit less tech and a little more just idea. Yeah. It is a container for values, but that's missing half of it. Your hand was next, and then I'll grab you. It is a thing with properties. You are still correct, but still missing one piece. Potentially, yeah, most likely key value pairs. You're all telling me things about the data. You're missing a piece. Your hand was up. Give me your version anyway. I like that you called it a noun. That's an awesome thing. So if we really break it down, thinking about objects as nouns is not the worst thing in the world. And the reason thinking about them as nouns is a really good way is because when we defined them in our code, they are the actors, the cast of our play. Objects are the data, as was pointed out by multiple people, that we're going to be working with. Here's the piece that was missing. When we are talking about things grammatically, which is appropriate when we're talking about code, because programming is a language, it's not math, what goes with nouns all the time? Yeah, verbs, right. So nouns are useless if they don't do anything. So what we have to think about when we're thinking about what is an object is that an object is data and the methods to act on that data in a single entity. So it's not just static data. An object is not ever just static data. It is always data and the methods to work with that data wrapped into a single thing. And this is an important concept for us because in JavaScript, we have a basic truth. Everything is an object. Based on the fundamental principles of what JavaScript objects are, everything in JavaScript is an object, even functions. Functions are objects. And yes, as was called out, we have properties, we have key value pairs, we have attributes, whichever synonym for that you want to bring into it. But ultimately, everything is an object that can then do things. And understanding this fundamental piece starts to unlock a lot of the syntax pieces that often give JavaScript developers some struggles. Because if I look at something like, let's say I make an extremely complicated list like this, right? Fancy data, I know. It's an array. It's an array filled with number objects. So there's technically 6 different data structures on the screen right now. But that list, I can then turn around and do list.map, or I can do list.forEach, or I can do list.length. Length is a property. Map and forEach are methods. So this is me now taking that data structure of I've got 5 numbers stuck together in a single entity. That is one unit of data, and there are properties and methods that I can use to work on that data. So this is where we get our flexibility, because what we want in this case is we want a data structure that we can use that mimics the world around us. All of the data structures that we use, whether it's database tables, whether it's objects, whether it's arrays, we define these things, and languages are built around these concepts because we need to mimic the world around us, because we're solving problems for the world around us. So if I think of this as a deck of cards, and let's go so far as to, say ace, king, queen, jack, etc., etc., etc. And then I turn around and say deck.deal. That would make logical sense, because now I have the data, which is this collected set of cards, and I have this method to deal those cards out. Now, admittedly, this is just an array. There isn't a deal method on that, and I'd have to come up with a whole bunch of other stuff to make that happen. But this now mimics how I would interact with this data in the real world. So in order for this to start to make even more sense, for us to peel back the great big emerald curtain. Oh, quick question. Has anybody not seen The Wizard of Oz? Good, no spoilers. Okay. So into The Wizard of Oz, Toto grabs the emerald curtain, pulls it back, and we see the guy back there with all the gears and levers, and the big head roars, pay no attention to the man behind the curtain, right? Well, we tend to pull that curtain down and set it on fire because we need to be able to know what's going on underneath. So in order for us to do that, let's talk about what an object is. I'll make this look like JavaScript. So I'm going to create an object. And I will put some properties on it. And for whatever reason, it's doing a tab size of 4 again, and that ticks me off. There we go. So I've defined an object, and this is what we would call the object literal syntax. I have created one object in just the most literal, bare bones way, and I have done it by using curly braces, mustaches, handlebars, whatever you want to call it. I've used curly braces to tell JavaScript syntactically, hey JavaScript, I'm creating an object. So then what I did was I used the syntax to create key value pairs. And these key value pairs are important because they mimic something else that we use in our real life. Admittedly, we call it Google now, but there used to be these books that you would open up and scroll to. Yeah, I say scroll, but you'd actually just run your finger down the page and flip the page. I saw a great video. It was, I think it was one of the like Funny or Die or College Humor or something like that. And they had put an encyclopedia in front of a kid, and they told him he had to look up, like, you know, it's like tanks or something like that. And he just opens up the book and he starts doing this on the pages, trying to get it to move. And I'm like, yeah, sadly true. But back in the old days, there were these things called dictionaries. And what are dictionaries? Well, dictionaries are a device where we take content, we take data, and we index it by having a word that is in order, and we use that word to then look up the definition. So this structure gets mimicked in programming quite frequently. Every language that I have ever come across has some kind of dictionary structure in it. Python, for example, calls them dictionaries, which unfortunately gets shortened to that, and we're not going there. But Python developers will use this phrase quite frequently. In fact, if you go onto r/Python on Reddit, there's a meme that keeps coming up where people take a picture of their screen and post it, where they've defined a dictionary, and it's a pic. I'm here all week, thanks. So you'll also see them referred to as hashes or hash maps in some languages. PHP, for example, calls them associative arrays, because they use array syntax, but there's a word in the brackets in order to look up, that's the key, and then you look up the value with it. So this is our basic structure for defining and understanding what the internals of an object are. So the key defines what the property name is. And an object is truthfully just this big dictionary where we define key names and then we assign some value to them on the other side of the colon. So that value could be strings, could be null, could be a Boolean, could be an array, could be another object, could be a number. It doesn't matter. As long as it's a valid data structure in JavaScript, it can be stored as a value in an object. So that gives us a cool amount of flexibility. And it's really powerful when you consider that if I was to, we'll name it something slightly different. If I was to store my data this way, so if I was storing it like this, word wrap, there we go. If I was storing it like this and I wanted to access things, it would not be quite as easy or as convenient, because I, as the developer, would then have to remember which order my data was in. And I would have to constantly, throughout the entire application, however big or small it might be, constantly be translating, oh, well, Don's, you know, that array 0 is the name, and array 1 is the email, and array 2 is whether or not they have hair. So that would be painful. It could be done, and very early programming dealt with it in that way. But if I can now put a label on what that data is through the use of a key value pair, that's way better for me. Because now I can look at the code and it's what we call self-documenting. Because if I choose to access a property like that through the use of the dot syntax, that's me saying, hey JavaScript, go to memory, look up this variable called Don, and then the dot is a property lookup operator. That is a specific piece of syntax in JavaScript. And once you've looked at about 10,000 objects and written, a million lines of JavaScript, your eyes tend to gloss over that dot. But that dot is a specific piece of syntax in the language that says, here's an object. I want to go look up a property on that object. And the name of the property is whatever is going to be to the right of the dot. So I'm telling JavaScript, go to memory, fetch that object, return it to me. I want to look up a property on it. Here's the name of the property I want to look up. And then that would return the string of my email. Now, that's really useful because I can look at that and have a very good sense as a dev, and even as a non-dev, I can kind of guess and intuit what that's going to be. Predictively, I know what an email is. I know what an email address looks like. I can assume that these are going to be text characters, and I know it's going to have an @ in it somewhere, and it's going to be @ something dot something, because that's the valid format for an email address. So it's a lot better than that. That tells me nothing. Now, it's not that that's wrong. It's not wrong. It would return the same, exactly the same value. But the object gives me a far better way to represent my data. I can type, I promise. So, now if I want to start representing things that I'm working with, like let's say, and let's, sorry, Bob, you're not an admin. But now I have a structure that if, let's say I had 1 million users, and all of them followed this same structure, then it doesn't matter which user I load up, whether it's coming out of a database, whether it's coming out of an array, whether it's coming out of, coming from an API somewhere, coming from a file that I loaded off the hard drive. If it matches this structure, and I want to email Bob, I now have a nice, consistent, easy way to do it. I can do things like I can write conditional statements based on these properties coming from an object. And this becomes super flexible and easy for me to implement in terms of building out the logic around my code. So, with that in mind, let's go one step further down the rabbit hole. So if we know that an object is this data structure with properties and with methods on those properties, then what are some of these methods that I have available? Does anybody happen to have a favorite object method that they were reading about last night on MDN to lull themselves to sleep? No? No? Okay. If it makes you feel any better, I don't have a favorite object method either. But what we can do is we can go to MDN, definitive source for all documentation, not W3 schools, and we can look at what properties are on the object. Length has a value of 1. Okay, that's odd, but it actually makes sense once you think about what's going on. Why would an object only have a length of 1? What if it has 1,000 keys on it? Right. We're not counting the number of properties on it. We're just counting how many objects there are. There's one object. If we were to do object.keys and pass in our user object, and then let's say we turn that into a variable, and then I say console.log keys.length. So if that was this object up here, this is a very different piece of code at this point. I'm not measuring the length of the object anymore. And you're like, object.keys, what the heck is that? Well, If we come down here alphabetically and we go to object.keys, it tells us it returns an array of a given object's own property names. So here we have object 1 with properties A, B, and C, and we do an object.keys, pass that object in, we get back an array that's a list of all the property names. Cool. So if I take my user object that I had, which is this one here with name, email, age, and admin, and I run object.keys on it, I assign that to a variable, then I console.log out keys.length, that's going to give me 4. Because keys at that point is not the object, the original user object. It's a new array that was created. Bless you, I was allergic to objects when I first started too. So it's a new array that contains those 4 strings in it, the names of the properties that are on the object. And so because it's an array, it also has a length property. Strings have a length property on them. Most everything in JavaScript actually has a length property on it. I can now measure that and say that it's 4. So I can find out really easily how many properties are on an object. In fact, if I wanted to be really kind of fancy with it, I could just do this. And I can just chain it all together. Because what's happening at each one of these points is each time I'm hitting one of those dots, what's to the left of that is something I've told JavaScript to go to memory and either get or figure out. So the first one here, this dot, to the left of it is my keyword object, capital O object. That's a built-in keyword in JavaScript that refers to the object. So JavaScript's going to give me that object back. And I'm going to say, hey, JavaScript, there's a property on you called keys. Please return that to me. And here's where I'm going to talk about something that's probably going to start to melt your brain just a little bit, but I'm okay with that. This property keys, that's one operation right there. Keys comes back, and it's a function. It is the definition of the function. Then we put parentheses on the end of it and run the function. This is another thing in JavaScript that we tend to get very like wax on, wax off, hand wavy about, because we see a function name followed by parentheses. We're like, oh yeah, that we're running the function. That's actually a 2-step process. The first step is going into memory and saying, hey, there's something named keys. Give me that back. Oh, this is a function definition. I'm now going to put parentheses on the end of it and run it. Yeah. 100%, yes. Yeah. Yeah, and now you're starting to get into some of the flexibility of what JavaScript allows you to do. And we're going to come back to this function thing, I promise, but I get the keys property back. It's a function definition. I'm going to run it and pass it an argument, which is my user object. That's going to run that function, and then I'm going to get something back from that function. Because functions always return something. Even if it's undefined, it's always going to return something. And so then I'm doing a dot on what that function returns. That function, in this case, is returning an array to me, because that's what object.keys does. So it's returning an array, and so this dot is actually working on the array that comes back from this function, and then I'm checking for the length property of that. So this starts to be where objects get really powerful, because if we know what JavaScript is going to give back to us, what kind of object we're going to get back with each step of the coding that we do, then we know what properties or methods we have access to in order to keep working the logic of whatever solution we're trying to build. So as a developer, one of our biggest jobs is not memorizing the documentation and trying to, stuff all of JavaScript in our head. It's knowing when looking through a line of code, step by step through that, what the return value is going to be. That's the far larger challenge that we have as developers. If we try and memorize JavaScript, it's going to be fruitless, because even if you somehow did manage to memorize every method on every object and every built-in thing that there is in JavaScript, by the time you get done memorizing all that, the language is going to change. And you're just going to have to etch a sketch and start all over. So it's way more important for us to be able to look at a line of code and be able to trace in a step-by-step manner, because it's not always left to right, it's step-by-step, what is being returned at each step along the way. And understanding the structure of objects really allows us to do that. So let's redefine our user object here. We're going to redo Bob. And now what we're going to do is add to our user. So all I've done is I've added another property to the object. And this property, the value that's stored in it, is a function. And now I have the ability to say user.name. And that, of course, is going to give me back Bob. But I can also do user.sayHi. And this is going to give me back this, it'll output the string hi. So when I was talking earlier, and I said that data and the methods to act on that data in a single entity, we talked about arrays. We've looked up some of the methods that are on built-in variables like object. But now what we're doing with this object literal, with this user that we have defined, we're now defining our own nouns in JavaScript. JavaScript gives us a number of nouns. It gives us array and number and Boolean and object and function and all those. But now I'm defining my own nouns, so I may need to define my own custom behaviors. So if user is a noun, then that noun needs to be able to verb something. And now my noun can say hi. Now my user can say hi. And so here's where this gets interesting. I said I was going to come back to the function execution thing, and now we are there. This is also valid code. That is 100% valid code. And what we're going to do is we're actually going to grab this code. Can you guys see that in the back? Ish. Okay. So I'll hop into Node, and I will paste in my object. And so if I just request my object, it's going to give it back to me. And you're going to notice that now it appears differently than how I typed it in. Because that function is now compiled by JavaScript. Node has evaluated that code and goes, oh, okay, I know that is a function I can run. So it's not just going to give me the plain definition of it when I look at my object. It's going to say, this is a function. This is something that can be done. And of course, I can run user.sayHi, put parentheses on the end of it, and it runs that function. It outputs hi, and then the return value from the function is undefined, because I did not tell my function to return anything. By default, JavaScript has to return something each time it does an operation, so I get undefined. That's cool. But if I just do that, what is JavaScript going to give me back? Anyone want to take a guess? The function itself. In what form? Am I going to see like the actual Console.log hi. Okay. I refuse to either confirm or deny that he may or may not be correct. Does anybody want to take a stab at a different answer? Okay, all those who agree with him, raise your hand. Okay, all those who think it's going to be something different, raise your hand. All those too chicken to raise your hand, raise your hand. Okay. We get back that what is stored in that property. And we've already seen what that is when we looked at it above. That is JavaScript saying, I have compiled this function to run. So this is a reference to the function. Yeah.
But what if we want to get the value in the form of what the function actually does? Like I know there's a function called say hi that stores the values of that key.
Yep.
But I want to really know what, like, okay. So what, that doesn't tell me what it does.
Correct. Correct. So here's, I'm going to answer your question with a question which is a terrible thing to do, but once again, I'm okay with that. If you are actually inside the execution of your code, so we're in the REPL right now, so it's like we are running a program but just paused at every line. Why would you want to do that? Inside your code. If I have actually gone, like this is a file on my hard drive and I've typed node space object.js to run this file, inside that file as it's running, why would I want to look inside the function? Exactly. As a human, I'm going to open up my code editor, and I'm not meaning that to be snarky. Yeah. Exactly. Yes. And here's how. So I've created a new variable called thing. And what I have done is assigned to thing what came back from user.sayHi, which, as we've seen, is this. So now I can do type of thing. Anyone want to take a guess? Okay, I hear object. There's another possible answer. It's function. Yeah. What is stored in thing is a function. And so I can validate whether, a property, because if I do that, I grab another property, store it in a different variable. That's a string, because that returns a string. But user.sayHi returns a function to me. And so then, now I get to do something really cool. Thing, which is our function, and I put parentheses on the end of it. And it runs the function. So I point this out because I want you to understand that functions, being a special kind of variable, a special kind of object, have two different ways that we can reference them, which is we can reference them just as the native definition itself, a reference to that function, the same way that user.name is a reference to that string. So I can do that, and I can take the definition of a function, but in JavaScript very specifically as a special type of object, if I put parentheses on the end of it, I'm saying that what I expect to be in that variable is a function, and I now want to run that function. So those are two different pieces of syntax there. So hopefully going forward from now on, you will never look at a function call as being all together. It's actually always two things. Because with this line of code right here, what I've done is I've said, hey, JavaScript, go into memory, find the variable called thing, find something in memory defined as thing, return it to me, I'm expecting that to be a function, so I'm going to put parentheses on the end of it, and I want you to run that. And JavaScript's going to try and do what I say, because what happens if I do this? Well, it's not a function, right? So I get a type error. User.name is not a function. But it went into memory, grabbed what was defined as user, returned it, which was an object. I said, hey, now I'm going to do a property lookup with the dot. JavaScript's like, cool, I know how to do that. I'm looking for the property called name. JavaScript went into the object, grabbed the property called name, grabbed its value, returned it to me. Cool. And then I said, hey, JavaScript, run that as a function. And JavaScript's like, no, not doing it, sorry. Hard stop, hard pass. So that's why the parentheses are a very different bit of syntax. If we go back to our really complicated list here, that's why this as one piece of syntax and that as a different piece of syntax do different things. So just like, and we're already comfortable with this with arrays, that I can reference the entire array, I can reference the definition of the array just by saying list. But then if I want to access some of the special behaviors of that object, I can put the square brackets on the end of it. And in basically every programming language you're ever going to come across, square brackets mean we are working with a set of data, and parentheses mean we are working with a method. That's just a standard that has been developed. So I can take list, I can stick square brackets on the end of it, and expect a different behavior out of it, because now I'm accessing something unique about that object. So, anyone's brain melting yet? Okay, just one. That's good. Good ratio. I'm now going to fix that and ruin all the rest of you. This is also valid JavaScript. What's going to come back? Bob. I can also do and get back my function, which means I can also do that, which is gross to look at, but does exactly what I would expect it to do. Why does this work? Well, it works because of the principle that I just talked about, which is in programming, if we take a variable and we put square brackets on the end of it, we're telling JavaScript that we want to interface with this as a set of data. And so what JavaScript objects give us the ability to do is if we know the name of the property in advance, like I know that I want the name of the user, I can just do user.name. But what if that value that I want to look up, like the property name that I want to look up, what if it's coming from somewhere else? What if, I'm filtering hockey players by their stats, and I'm asking the user, hey, which stat do you want to filter by? And they're like, oh, I want it to be penalty minutes. Okay, well then I need to pull different values out of my objects, and I don't know what that's going to be ahead of time. I need to have a way that I can dynamically grab a property. So JavaScript gives us the ability to access the list of properties using square bracket syntax. So I can say, I can just take a string like email, stick it in a variable somewhere, and then I can do user prop. And I get back the email property of my user object. The big difference here is I can't do this. I'm going to get an error back, well, not an error, but undefined, because that is not, there's no property on user called prop. The dot does not do any evaluation after it. And this is a key thing for syntax in JavaScript. Pardon me. If you are accessing a property using the dot syntax, there's no evaluation. So you can't name a variable and then you do user.variableName. It will never work. If I'm doing that if I need that evaluation to happen, I do square brackets. And then it evaluates whatever's inside the square brackets and uses that to look up the property name. So that's why I can do this up here. That's a string called say hi, and that could be in a variable, totally fine. But the string say hi is as evaluated as it's going to get at that point. JavaScript uses the square brackets to say, go look at the list of properties on this object, see if there's one called say hi, and if there is, return what its value is. Well, it returned it to us. We know it's a function. I then stuck parentheses on the end of it and got, had it evaluate it. Which means I can also do something really crazy like this. Because what does that function return? That function returns, haha, gotcha. There is no length on undefined. Console.log is not a return. Console.log is output. I can, that's valid code, but I'm going to get a type error because undefined doesn't have a length. But if I was to change what my function does, and then do the same code over again, now I get back 3, as you would expect, because now my function is returning a value instead of just outputting it. Cool, so it's about 10:45. Let's take a 10-minute break. Let that kind of soak into your brains. And when we come back, we'll go even deeper down the rabbit hole. Yeah, sure.
Of the dot versus like the square bracket.
Yeah.
So for like if you use the dot, it's only one evaluation because it's going into the properties. Whereas for the square brackets, is it bringing user up first and then like returning user and then getting like the prep and then returning that? So that's 2 evaluations then.
Technically, but it's optimized behind the scenes. Basically, the syntax of the square bracket on an object says, do this lookup on the list of properties on that object. The only time you're going to get 2 evaluations is in the case where I had like this variable prop here.
Yeah.
So then it has to evaluate prop and then look up, but it's optimized behind the scenes so that it doesn't slow down if you're using. It's almost faster to use the square brackets in truth because that's the original way of accessing all object properties. So that's been in JavaScript since the beginning.
That's kind of like how arrays.
Yeah, very similar.
And so like if it was like an array, for example, then like it's not accessing like that index in the array, but it's returning the array and then accessing that index.
Yes.
Okay.
Yeah. Always. Yeah. Cool.
How did you get? Why does it 3?
Okay.
2 of us are wondering
So I changed my function so that it's going to return this string.
Yeah.
There are 3 characters in the string.
Okay, that makes sense now.
Yep. Because before it was returning undefined.
Yes.
And undefined doesn't have a length
Right.
because there's nothing there. Yeah.
Okay.
You're welcome. What's your question?
So when you use the user square bracket prop,
Yeah.
it gives you the email, but when you do dot prop, it doesn't. Is that
Right.
because when you use the dot,
It doesn't evaluate what's on the right-hand side of it.
then when you use the dot property, in order for it to work, does that need to be in an object, like curly braces?
Well, no. In order for that to work, whatever I have to the right of the dot has to be the name of one of the properties. Literally, the name of one of the properties.
You're saying since prop is equals to email and email equals to the bob,
Right.
it doesn't skip twice. Is what you're saying. When you use the dot prop, when you use the dot prop.
Well, basically, what I'm saying here is because like this prop could be set to any string, really anything. I'm saying I want to take whatever is stored in this variable, and I want to look up that property on the user. I mean, prop is just a variable name. It could be Fluffy Bunny and still work. Whereas here, I'm saying I'm looking for exactly the property named prop. So this is a name, not a variable at this point. Yeah, so no evaluation is done of this on the right-hand side. Even though I have a variable defined named prop at this point, this does not get evaluated at all.
So that only gets evaluated that exactly
If I'm in square brackets.
in the user object.
Right. Yeah.
Do you mind if you scroll up a bit?
Sure. More, less.
Down. Oh, yeah, around there. Oh, you know how you did thing round bracket?
Mm-hmm.
And you say round bracket act as a calling looking for a function.
Yep.
If you just do thing in this case,
Mm-hmm.
where thing is defined as user.sayHi.
This is what I'm going to get back. Because that's what's stored in thing, is the reference to that function.
Okay.
Yeah, in fact, it's still defined, so. So yeah, there's a difference between looking up a function and running that function. Those are two different steps.
You're always coming back to the reference, like the thing.
Mm-hmm.
Pretty much the reference is looking at whatever user dot say hi is.
So what's actually happened here is an interesting thing where it's made a, it's thing is storing a reference to that function on that object that is named say hi. Yeah. Okay, let's dive back in. So we've got our user object that we've been working with up to this point. So what I'm going to do is I'm going to define a function. And what I'm going to do is define that. So I have a function called replaceObject. It takes one parameter, and I'm going to take that parameter and I'm going to assign just a blank empty object to it. So I'm going to call that function, and I'm going to pass user to it. What are we going to see? This is your pop quiz. Yeah. Not quite. Yes, undefined is coming up because I'm not actually returning anything from the function. Correct. That's what's happening here. When I run replaceObject user, what I'm doing is ref is a local variable to that function. So I'm taking user, and even though I'm passing user into ref and reassigning ref, once that scope is done, once that block is done, that ref goes away and user stays the same. So, with that in mind, so I've now run that. And based on what we just learned from this, what am I going to see? So, this is where JavaScript is unlike many other languages. So, there are two ways that programming languages typically work when it comes to doing this kind of passing a value. And they have names that are called pass by value and pass by reference. So pass by value is if we took the user object, we made a clone of it, put it in that local variable ref, did whatever we were going to do to it, and then when that scope went away, that copy, that clone went away. The other way we can do it is what's called pass by reference, which is where the same thing that we did when we passed thing, like we did user.sayHi and we stored it in thing, that became a reference to the function on user. So in this case, in actually both of these cases, what's happening is that we are passing a reference to the original user object. The reason that the first one didn't change anything on user is because ref and anything that happens to ref, like getting reassigned here, ref is a let variable. It's not a const variable. So that allows me to take a new data object and assign it. But because it is a let, it is block scoped. So basically inside those curly braces is the only place that ref exists. even though ref originally had a reference back to user, I didn't change user, I replaced user. So that reference got replaced by a new object, and nothing happened to the original user. We literally went, oh cool, you gave me a reference to something, don't care, new object. That's literally what happened in the replace object function. And because it was effectively working as a let variable, once the scope was done, the function body was done, that variable just disappears, goes away. But in the other function, we passed in a reference to the user, and then we changed that user. We didn't reassign, we didn't replace it with a different reference. We actually changed the reference that we had. And so as a result, our original user object gets a new key on it. But if I was to reassign ref to something different, then we're not referencing the original user object anymore. So this is where objects, but when you're passing objects into and out of functions, you do have to be a little bit careful, because you can end up in some interesting scope situations with getting your object updated when you don't expect it to. You know, let's say that I do this. Now when I look at user, Bob, as opposed to just Bob. Or if you're a fan of Outkast, B.O.B. But that's different. Good song though. This happens and this works because even though ref is let scoped, I'm assigning a property to ref, so I'm updating that reference, and whether this was a name, whether this one was an existing property or not at this point doesn't matter. If it doesn't exist here, I'm going to have a problem. Because if it doesn't exist, I can't to uppercase on undefined. So this function only works if what I'm passing into it has a name property. But this gives me a way to uppercase the name. But let's change things just a bit and go back to talking about our square bracket. Traders. Not terribly different from a logic perspective, different from a syntax perspective. Now, for example, in order for this to work, I have to pass 2 arguments to this. So if I want to run this, I can pass user and then let's say email. Now, let's talk about what this is going to do before I run it. User is going to go into ref. The string email is going to go into prop. And what I'm going to do is I'm going to say, I want to assign on this object, ref, a new property called prop, whatever's in the variable prop. It's not ref.prop, because that would literally be creating a property named prop. So whatever is stored in the variable prop, I want to create a property on ref called that. And what I want to store in there, the value that I want to put in there, is fetching whatever is currently stored in that named property and uppercasing it. So this is going to function, if we're just talking about this part of it right here, ref is going to go and give me my user object. The square brackets say, hey, I want to look up the list of properties on here, and I'm searching for one of them. What I'm searching for is whatever's stored in this variable. So this gets evaluated as a variable, which is going to be the string email. That's what's going to get returned here. So it's going to be ref square brackets, quote, email, close quote. So it's going to go find that property on the object and return this string. That string, we're then going to attach dot to uppercase to it, because that's a method on string objects. We're running that as a function, and that's going to return to us a new string. Theoretically, with all of this uppercased, except the @ sign, you can't uppercase an @ sign. And that will get stored in ref square bracket string email. And ta-da. We could, just for demonstration purposes, slightly different manipulation here. But if I call that like this, then what's going to come back is undefined. But then I look at my user, and Bob is now still 25. Why? Yeah. Great debugging. Pretend I have a stack of virtual cookies on the podium. You just got one. Do you want to explain to everyone else why that did what it did?
Yeah, because the plus plus I keep at that back, the value will return it after the function is run, right?
Yeah.
So
And now Bob's old. So this is another interesting thing that we run into is we're like, oh, well, you know, hey, this is a number object. Number objects have all these cool math things that we can do with them, right? Great. So plus plus is our increment. It's also called the unary operator. But it's our increment operator. And so it should take that value, increment it by 1, and then that's what should get stored in the key, right? That would make sense if we were reading it from left to right. Unfortunately, that's actually not what JavaScript is going to do. Plus plus, you have to remember, is the same as that equals that plus 1. And because of a funny thing with the order of the return values, this is going to return 25 and store it here, and then go, okay, now I'm going to increment by 1. Whereas if I swap it around and tell it to do it this way, really, please go away, like now, thank you. There we go. When I swap it around, I'm telling it, take what's in ref prop, and then increment it and return that. So there's actually a couple different operations happening here at the same time. By putting it ahead of it, I'm saying that I want you to go get this value and then increment it by 1 and return that to the assignment. Otherwise, what ends up happening is this becomes one operation, and then we plus plus that. It's a weird thing. So another gotcha, but this one's with number objects. So this is getting into the pass by reference versus pass by value, but it's also showing us how we would change things in terms of using this dynamic property. Yeah, question?
yeah, before you go too far on that question, what if you really want to like rewrite or the
Mm-hmm.
method. Is that possible, or is that impossible to do it?
When you say rewrite,
Or just change the object, the whole object, the same thing, right?
right?
Inside the function, use the similar method. Is that possible, or is it impossible to do it?
Oh, you mean doing it inside the object itself?
No, it's like write a function
Mm-hmm.
like a ref, and like you like just did, you press the user, it's an empty object, right?
Mm-hmm.
Override it. Is that possible to?
So you mean actually doing something like this?
Yeah. Oh no, it's like ref equals
Well, that was the replace object that we did up here. This one here.
yeah, this one. But,
Yeah.
What if you really want to change the?
So if I really wanted to overwrite that object. So here's the interesting thing. Technically, because I defined user as a const, I can't reassign it. So I can't take a new object and assign it to the variable user. The only way I could do that is, if I tried to do this, not doing it as ref, because we know ref isn't going to work, because ref is let scoped. If I try and do this, and I don't even technically have to pass anything to it, I'm going to get an error of assignment to a constant variable. So later down the road, when we get a little bit deeper into data structures, there is the ability to delete keys from an object. So literally what I'd have to do is I'd have to loop through like object.keysUser.forEach and delete each key from the object, which is just gross. It is possible to empty out the object, but I technically can't reassign it or replace it with an empty object because I defined it as a const. If I had defined it using var or let, then I'd be able to do that, but I can't because it's a const. Yeah. Yeah. Mm-hmm. Great question. So, when in assigning something as a constant, what we are doing, and I'm going to guess you have a programming background in either C or Java. Okay. So this is making your brain go, oh dear God, how does this work? Sort of. So what happens is in languages like C or Java that are a little bit lower level, like talking directly to the hardware, when we create an object or an array, we have to define how big that array is going to be, for example. And if that array gets bigger, we actually have to create a new array, copy the values from the first one into a new bigger array, and add extra values to it. So JavaScript does kind of dynamic memory allocation. Unfortunately, it sounds fancy, but it's really not. The way that constant works in this case is constant gets an object reference, so for a particular address in memory that the memory has been allocated to store however much you want. And const as a keyword says that address cannot be changed, but things inside that space can change. So like my list that I have that I've been working with, so I can do like list 5 equals 6, and that's totally fine. I can keep pushing, I can keep adding elements to the array, but I can't actually push to it. Actually, it may let me. Yeah, it will. Okay, so I can push to it. But what I can't do is say list equals, like change it like this. I can't create a new object, like a new space in memory, and try and assign that to that variable. Whereas let literally says, we will let you reassign this if necessary.
So you're talking about how you can, and this is beyond the scope
Mhm.
of what we're talking about right now, just curious.
Yeah.
You can pull stuff out of that assigned location for information.
Mhm.
You can go through the whole thing and remove everything. All you're basically doing is saying hey, there was something here, but smoke and mirrors, there's nothing here now. It's still like there. but
No,
it's-
actually, once you delete it, it's gone.
Oh, it's actually.
Yeah, it's actually gone. This isn't Windows. That was mean. I work for Microsoft, I can say that. Yeah, Windows, when you delete something, it's never actually deleted until you like rewrite it like 10 times or overwrite that place in memory. Yeah, no, if I go through and I delete those values, I can't get them back. Like
So
if
you'd
I,
have to clear out the whole thing, and then like the data would just not be.
it would,
But you can't touch that.
yeah, I could go back and add new properties,
Yeah.
even if they were the same data, but they technically be considered new properties. Yeah. So, when you had asked your question about replacing it, I'd actually thought you were asking a neat question, which gets us a little bit further down the road or deeper down the rabbit hole, depending on which way your brain's going at this point. Because what if we want, like, we know from our user that this says hi. You know, we know that that returns that string. But that doesn't tell us which user said hi. I want, you know, kind of this template behavior so that no matter what user's data is in this variable, you know, is in this object, when they say hi, I know that it's Bob saying hi or Sally saying hi or, you know, whoever saying hi. So how do I get a function on my object to be able to look at its own data? This, yes. So quick linguistic disclaimer, this is the worst thing in JavaScript to talk about because it's called this. So I end up saying things like this, and that, and that's why this is cool. I literally mean this, and you don't know whether I mean this or this. So this will be fun. So I'm going to make a new property on my object. And I'm going to run it as a function, or store a function in there. And what I'm going to do is say that. So different function. And in there, I have stuck the code this.name. And you can go read 100 blog posts about this. In fact, I encourage you to go read 100 blog posts about this. Everyone has their way of explaining it. And all of them are going to say basically the same thing. I'm going to give you my tried and true, always works, one sentence definition of how to understand this. This is always a reference to the object that called the function. 100% of the time, without fail. And that means if I run user.reallySayHi, this is a reference to user. And the way that you can figure out which object called the function is what is called left of the dot. So I look at this invocation of this function. I find the dot. It's right there. It's pretty easy. And then I look to the left of it. That tells me inside that function what this is going to be defined as. Bob says hi. Whatever the last thing is, that's the. Yeah. And we're going to get there by the end of the lecture, yeah. Just user. Yes. There's an asterisk on that, which we'll get to next week, but it would be just user.
So it would be like a mirror. It's like it's
Yes.
letting itself look at itself. Like without it, like or without this, there's no mirror. It can't see itself.
Correct. And I love that you're using the term mirror because this is what we call a reflective keyword. So it literally reflects back, a reference to whatever called it. So this only exists inside of functions. When you use the function keyword, this automatically gets defined by JavaScript. Yeah. If it ran that function, yes. Yeah. And it also, the other big benefit to having the this keyword is I can now say, I can rename our user and call this function again, and now Sue says hi. So it looks at whatever is, basically it gives us an object reference. It's like I defined, const this equals whatever called me. And then I say, so this gives me a reference to the user object. And then I say, hey, I want to look up a property on that. And the property that I want to look up is called name. And I want to concatenate that to a string that says hi. Yes. Yeah, but now, here's where it gets kind of interesting. So, we're going to make another person here, and we'll even give them some of the same attributes. We'll promote them way above my pay grade. And so now we have this other object. And what I'm going to do is this. So user.reallySayHi with no parentheses after it is a reference to that function. I'm creating a new property on other person called sayHi, and I'm going to store that function in that property. Now I want to run that function. What is this going to say? Say it louder. Yes. Because in this case, left of the dot is other person. Even though that function came from user, it's now being run by other person. So left of the dot says, other person, go find the name attribute of that object, concatenate it to says hi. And if I rename Sally to, let's say she decides she's going to take on her middle name as well. Maybe she's from Alabama, we don't know. We don't judge. Then it behaves as we would expect. Whatever is in that name property is fetched because we are able to reference the object that called that function. So this is really powerful because it allows you to get access to properties inside the object. Cool? Cool. Awesome. So if your brain looks at this and is like, nope, I'm not doing that right now, later, totally fair. This isn't something that you should be able to get immediately. You can probably see the shape of it and go, yeah, that might be something interesting that I can use, 14 years from now. And it is. But I will encourage you to keep working with this so that you are able to do this. And I'll send all this code out, don't worry. But be comfortable with the idea that it exists. I do encourage you to go and read a whole bunch of blog posts because a lot of really smart people who write really well and a whole bunch that can't have written blog posts to try and explain this because it is a confusing, sometimes amorphous concept. And JavaScript the good news is JavaScript is consistent with how this works. So go read it, but most importantly, sit down, set aside half an hour for yourself and say, I'm going to learn this by doing this. You can't learn it by reading it. You can only learn it by doing it. The reading, though, will help you understand what it is you're doing. Question?
I can see why you would do something like that.
Mm-hmm.
Find other person and say hi to that, so you don't need to keep rewriting it.
Right.
But I would write a function outside the user,
Mm-hmm.
so I could do the same thing. Is there a reason to actually, should I be trying to do stuff like that, or?
I'm going to give you a terrible answer. The short TLDR is yes, you should be doing that. The longer answer is there's something that's outside the scope of this lecture in JavaScript that allows you to take any function that exists anywhere in your code and run it with the scope of an object. So I can take any function from anywhere and run it as if it was on the object that I'm giving it, and that allows me to change the scope of this. all of the array functions we have, like for each and map and reduce and inject, all those. Actually, inject is Ruby. Never mind. It's reduce in JavaScript. All those methods can take a parameter that allows you to change the scope of this. So it is good to understand that you can write a function that uses the this keyword as a way to get some property of whatever has called that object. And then as you get deeper into the syntax of JavaScript, we will get to how you can apply that function to any object in your code. And then it will open up this wonderful world where now let's say that you want to calculate tax on a transaction object. Well, you just have a function that grabs the country and the province and the city that they live in, goes and looks up what the tax is, automatically calculates that tax and returns a total to you. And now that doesn't have to live on the transaction object. It can just be a function that's somewhere in your code. It could be in a different module, whatever, and you can now apply that function to your object.
Is it like if I have like array dot length and I pass an array, or I have the array dot length, I would be essentially doing the same thing. Is this something along this?
No, nothing like that whatsoever. This is where I say, have you ever had spaghetti? You say yes, and I say it's nothing like that. Yeah, like I said, outside the scope of this, but I will just say the keyword is apply here. And if you were to go and Google about JavaScript and apply and functions and this, you'd learn a whole bunch. Yeah, question? Okay. You can, the scope changes. It's no longer a reference to the object that called that specific function. And that's also outside of this. Outside of this, not this. Yeah, arrow functions don't reassign the context of this. It stays whatever it was before that function was called. There's always a this defined in JavaScript, always. Whether or not it gets reassigned is depending on whether you're using the function keyword or the arrow.
I think I'm just going to be confused if I don't get it.
Go for it.
Answered. So the thing that you're talking about is like a modifier to this that would redirect what it's
Being set to.
Yeah.
The short answer, the TLDR to all of this is you as the developer are ultimately in control. JavaScript has really consistent rules as far as what this is going to be assigned to, or what's going to be assigned to this. But you as the developer are in control and can modify that if you need to. The trick is learning when you need to. Yeah, cool. Moving on from this and this. So, the other thing that I want to talk about when it comes to objects is, I referenced it earlier about what we can store in the value of properties. So we've looked at numbers, we had a null, we've had strings, we've had functions. And because all of these are just objects, we can store any object of any data type in the value of a property. So that means we can also store arrays in there, and we can store other objects in there, which gets us closer to your A.B.C example. So what we're going to do is we're going to create a new object for ourselves, and let's call it, well, let's just call it album. And the album, the artist is going to be Bob. Great, he's a great artist. Are there anybody named Bob in here? I've never had a Bob student before. If I ever do end up with somebody named Bob, I'm in so much trouble. I have a rubber duck which sits on my desk. His name is Bob, and it's why I jokingly use Bob for all my names. Bob's seen some stuff because he's been with me for like 9 years. Yeah, so all of my example names are almost always Bob. So fair warning. But we've got an album. The artist is Bob. The title of the album is Bob's Greatest Hits. Released in 2019. That's an integer. And now what we're going to do is we're going to have tracks. Well, track, if you think about the track of, on an album, by the way, there used to be these things called albums that you physically bought. You didn't just stream it on Spotify. They were great. They were an experience. Artists actually cared about the order of the tracks and how many there were. But there are a collection of tracks on an album. So anytime we have a set of data, we're going to represent it as an array. But each track has data associated with it. It's not just like the name of the track. There's like the name of the track and how long it is, and if there's, I don't know, writing credits or a guest singer or something like that. So we're going to have to use an object to represent each track. So we're going to say, well, the first thing is the order. So we'll say this one's first, and the title is, Hey, It's Wednesday. It's a really timely track. Duration. So here's where we get into a little bit of theory in terms of storing data. Anytime you are storing time or money, reduce it down to the smallest unit. Because if I try and store this as like, let's say 3 minutes and 30 seconds, I'm going to have to store that as a string of 3:30. But then, if I want to know whether that track is longer than another track, I have to convert that to a number. So I'm going to have to convert it to the number of seconds anyway. So why not store it as the number of seconds? And then, if I need to display it as 3 minutes and 30 seconds, that's a one-way conversion of it instead of having to convert it backwards and forwards constantly. Same thing with money. Never store money as the string or even as a float of like dollars, cents. Always store it as pennies. Even though in Canada we don't have pennies anymore, always store it as pennies, because then it's a lot easier to work with math-wise. So I'm going to store it duration of 210 seconds, and then we'll add another track, and we'll say, actually just for fun, we'll say that it's order number 3. Title, yesterday was Tuesday. That one's a throwback. This one is going to be 240 seconds long. And last but not least, on his big 3-track album here, title, Monday was a long time ago. This one is his longest song, and it's 333 seconds. So close my array. And then let's say price is going to be that. Oops. Oh, my fault. Let me do that all over again. Artist Bob, title, released. Put a comma after that. Price, $24.99. Now I'm done. Cool. So now I have this object. And it doesn't have any methods on it, it's just data. And I can see all of the data. But there are things that I now have as a developer, some challenges I need to figure out if I want to work with this data. This could have come from an API. This could have come from a database. I could have loaded this from my custom, album tracker app that I made for myself. Doesn't matter where the data came from. This is the format I'm getting it in. So now if I want to work with this data in a way that gives me meaningful insights, which, by the way, is all software is. It's working with data to get meaningful insights. That's all we do. Nobody hires you to code, by the way. You're like, crap, I just spent like all this money on a boot camp. But yeah, nobody's going to hire you to code. That's not what you get hired for. You get hired to build and support products. And products are just taking data and giving people value on accessing that data. That's all we do. So if this is the data that I'm working with, if I'm a dev for Spotify or Genius or something like that, well, I'm going to have this kind of data and I'm going to have to work with it all the time. If I'm working for QuickBooks, Intuit, I'm going to have a whole bunch of financial data about accounts and transactions and invoices and bills and all that. And if I'm working for BuzzFeed, well, I'm going to have a whole bunch of, checklists on the top 24 ways to eat jellyfish. Number 6 will blow your mind. That's the kind of stuff I'm going to have to deal with. So I have to be able to pull out the metadata that's in here and make it meaningful. So let's start with something like, let's say I just want to find out how many tracks are on this album. So I know that tracks is an array. And I know that array, I can count how many things are in the array using .length. So if I can get to that array, I can call .length on it, and that will tell me how many tracks there are. So I could say something like const tracks equals album.tracks, and then tracks.length, 3. Awesome, that's right. But then I can look at that and go, well, actually, if all I have to do is just do album.tracks, I can now just do album.tracks.length. That gives me 3. And it's because I know from what we've just talked about all morning that this is the first step. It's going to go into memory, find album, return what's stored in it, which is the whole object. And then I'm going to use dot to look up a property. The property that I want to find is named tracks. And so that's going to go look in the object and return whatever is stored in the tracks property to me, which is an array, which I'm then going to look up a property of using the dot. And the property that I want to look up is length, which is automatically created for me by JavaScript. And that's going to give me back the length of the array. Awesome. So now I can start to work with this. Now let's say that I wanted to find out the title of the first track. Well, I know that album.tracks gives me access to that array. So basically what I'm always trying to do when I'm working with a complex data structure like this is I'm trying to get myself to the point that I'm getting the right return value to work with. So this is why I said it's not about memorizing all the methods, it's figuring out step by step what return value I can work with. So if I know that I need to get that array back, then album.tracks is going to give me that, because there's the array right there. So album.tracks, if I want the first one in the array, well, I can just stick 0 on it, like array index 0, and that gives me that object. This is also the great thing about a REPL, like, just going into Node like this, is I can experiment with my data. I can test my assumptions and make sure it works here. And worst case scenario, I type .exit, enter, node, enter, and I've just wiped out all the memory and I can start fresh. 96 milliseconds of my life are now gone, but I can do the Etch-a-Sketch thing if I mess up my data somehow. Not a big deal. So if I want to find out the title of the first track, well, here I've now figured out I can chain album to tracks, tracks to array index 0, and then .title, because what's being returned to me is an object, and I can look up the title property of that object, and hey, it's Wednesday. So now what we're going to do is really mess with your brain. What if I want to find out how long it would take to listen to this album from start to finish? Like if I was going to binge listen to this awesome album. Yeah. Yep. Yes. So there's actually about 5 different ways to do it, and your way works. I'm going to start off with the most naive and then work forward incrementally. Yep. Yeah, I'm already, yeah. I could do like a 4 of 4 in kind of thing with album.tracks and then add up that way. Basically, the basic premise is I'm going to loop through the tracks and add up the duration. How I choose to do that loop now becomes honestly a question of preference and style more than anything else. As long as I understand that at a basic level, I need to do a loop over this data and add up the duration property, the value in the duration property for each object, that's the solution. Everything else after that is honestly just semantics and style. And that's why we say things like software development is opinionated. Because I could for each it, I could for in it, I could for of it, I could just write a for loop, I could do a reduce, I could do, like there's a couple different things I could do to get this right answer. So yeah, let's do let total equals 0, album.tracks.for each. Do it longhand here, so function track. So track is getting passed in each time this for each is getting called. And so what I want to do is total equals total plus track dot duration. I could also do total plus equals if I want to shorten it a bit. I'm just writing it longhand for clarity's sake. And now when I look at total, that's 783, which is 783 seconds, which doesn't really tell me much. This isn't meaningful to me. So I'd want to do total divided by 60, which is 13.05, which tells me, okay, it's going to take 13 minutes to listen to this whole album. And if this is all Bob's greatest hits were, well, this is across 14 albums, so it's like you too. So this is how I can now start to iterate this. And so then I, just for demonstration purposes, like the reduce allows me to effectively do it in one line. And if I was doing that with a fat arrow function, it would be even shorter. And then I technically take that and divide it by 60. And I get the number I want. So, and that's me just knowing that what's going to come back from reduce is going to be the bigger number, and I can divide that by 60 and then get what I want. So now I can start to work with this a little bit better. What time are we at? Perfect. So the last thing is, one of the things I deliberately did when I was making this data is I didn't order the tracks correctly. So one of my challenges might be, how do I get these tracks to show up in the right order? Well, if somebody gives you a deck of cards and they're out of order, what do? There's a word for it. Ah, there we go. Shuffling puts them out of order. Technically it puts them in an order, but it's not necessarily an ordered order. Yes, sort is what we want to do here. Sort is a method we have built in to JavaScript. And so if I take something like this list here, I can just sort it, and it does what you would expect. Does what you would expect. Sanely, mostly, sorts things. Where it gets weird is if I do this. In the world of computers, capital letters come before lowercase letters. Cool, okay. So that's great, but if I do this, it comes back like that. So it didn't sort anything. Why not? It doesn't know how to sort this. So I have to be able to tell it what I want it to sort with, because these are objects, and it's just like, cool, objects, here you go. If you remember back to being a child, huh? Technically, it's sorting by the memory address in the order that they were created. Technically. Yeah. There is always a default, and JavaScript is always consistent in applying that default generally. But if we don't know what that is, or worse, we don't know how to modify it, we're then at the mercy of it. And if you remember, like when your parents were teaching how to drive and your dad probably said something like, you drive the car doesn't drive you, you write the code doesn't write you. So we have to now be able to figure out, well, how do I get it to do what I want? So part of this is understanding how sort works. Sort works by looking for a negative value, a positive value, or 0. And if it is a negative value, then it means that the second one is greater than the first one. So it takes two things, compares them somehow, and if it gets a negative value from that comparison, it says the second one is greater than the first one, therefore they're in the right order. If it gets back a 0, it means they're identical, therefore they're in the right order. And if it gets back a positive value, it means the first one is greater than the second one, and they have to be swapped. And that's how sort works. That's how sort works. So we need to be able to tell it to look at this order property and be able to use that. And so here's how we would do that. we would give it a function. And we would tell it to literally subtract the second one's order from the first one. And voila. If we wanted it to sort by duration, it's the same order as it was originally, but it's sorted by duration. That's because I'm incredibly uninventive in entering data. But it is now sorting by the duration. Technically, I could sort by the title as well, using the same kind of comparison. And we could do something really cool, where what we can do, well, actually, I'll just rewrite it. Now I'm reversing the order of them, B minus A. Descending order. It's still doing the same comparison. The functionality hasn't changed. I'm just saying I want it to sort in reverse order instead of ascending order. So now, 333 is greater than 240, so those get arranged in the right order. So yeah, that's how I can take data out of an object and then work with it a little bit better. And even if I was dealing with functions and things like that, it would always only be, to your earlier question, like let's say each track had a method on it that was then outputted the title formatted in a certain way. It would only be relevant to that track calling that function. Yeah, because I'm always only ever dealing really with one object at a time. Yeah, and it's the closest, smallest scope always. So yeah, whether it's an array index, whether it's a chain of object properties, all I have to be able to know is literally like what I've been doing of covering up pieces of the code. I encourage you to steal a sticky note from somebody and literally sticky note your screen so that you know where each piece, what each return value is. And anytime you're trying to figure out what a piece of code does, if you can follow through the array index, dot chains, or property lookups, or whatever it may be, if you don't know what the return value is at each point, well, that's a great time to give it its own variable, console.log it, go into the REPL, play with the same data until you are sure at each step along that way what that return value is going to be. And then debugging becomes a breeze. So speaking of debugging, because I have 6 minutes left, I'm going to give you a quick little lesson on debugging. I will say that in my dev career, debugging is probably the thing I became the best at because I actually have to thank Microsoft for it because the job that I had with Microsoft was literally to troubleshoot problems that existed in synchronizing their old MSN Butterfly software, if you remember the browser. May it rot in hell. So troubleshooting problems with how it synchronized with the servers. So I dealt with all the network stuff going in between the server and the client all the time. So I spent 4.5 years at Microsoft just debugging, basically. And I came up with this acronym, which is always great, but it has served me for now almost 20 years as kind of a truth of programming. And as a dev, anytime that we can have things that are just absolutes that we can rely on is a great thing. Especially because we just talked about there's 5 different ways to loop through a list, right? Well, if I need to know what always works. So when I'm debugging a problem, if I'm trying to figure out what a value is, if I'm trying to figure out what a function returns or how it works or what it's doing, I have to recognize that 100% of the time, the secret to code is LSD. Unfortunately, I don't mean acid. I know. I mean logic, syntax, and data. Every single issue you will ever face from now until the heat death of the universe is going to be one of these 3 things. At least one of these 3 things, possibly more. And there are easy questions you can ask yourself for each one of these three things to figure it out. Logic. Have I given the computer the step-by-step instructions to solve the problem? Programming is us telling the computer how to solve a problem, right? That's all it is. That means we as humans have to know the solution first. If we don't know the solution, it doesn't matter whether we're in JavaScript or Python or PHP or Ruby or Go or whatever, we can't build a solution. There's no do what I mean button. That's not yet on Apple. It'll be in the touch bar soon. But logic is, have I given the computer the step-by-step instructions to solve the problem? As a human, I have to take my solution and I have to break it down into steps so simple that even a computer can do it. And that means like down to the step-by-step. Take this number, add it to this number, return the result. If I haven't done that, and this is where rubber ducking comes in, if I can't read through my code and see step-by-step that it's doing what I would do as a human to solve that problem, then I have a logic problem. Easy to figure out. Cool. Syntax. Did I use the correct spelling, punctuation, and grammar in giving the computer the instructions? Those are English words. Those are words that we use to describe the function of the English language or any language. That is spelling, punctuation, and grammar. Guess what? Programming's a language. If I didn't capitalize the E in for each, it's not going to run. The logic is correct, but the syntax is wrong. If I try and put a space in between for each and the parentheses, the function's not going to run because the syntax, the punctuation of that, the grammar of that isn't going to work. So that's my syntax question. And last but not least, do I have access to the data I need in the format I expect? If the answer to this is no, you're dead in the water. If I'm trying to add two numbers together and I don't have two numbers, I can't do it. Yeah.
You're like referring to like in that sense, like not just like scope.
Not just scope, but format as well. For example, when you get into working with JSON, which is a data format for representing JavaScript objects, JSON is a string, but you need it as an object. If you're trying to use object methods on it, on a string, not going to work. So things like if I'm expecting true or false, and I'm getting back 1 or 0. Like I as a human can look at that and go, 1 is true, 0 is false. This is how JavaScript works. I get it. But if I'm expecting a Boolean, and if I'm trying to evaluate 1 triple equals true, that's never going to work. So I always have to look at what's being returned each time I call a function, each time I access a variable. Is it the data I need in the format I expect? Like when we were pulling album.tracks, I have to know that that is an array. That's the data type I'm dealing with at that point. And then when I go into that array, I have to know that that's an array of objects. And then when I go into that object, it's an array of objects, and then we have an integer value and a string value and another integer value, and I have to be able to work with those correctly. So not only do I, did I get data where I expected it, but is it data that I can work with the way I want it to? And then the way that I'm trying to work with that data, did I spell it right? Did I type it out right? And the actual method I'm trying to use, does it make sense to do that at that point? So these three questions are also why I heavily recommend, and I see most of you have it, which is awesome, actually having pencil and paper. Dead trees can often help us do wonderful things when it comes to technology, because I can now pseudocode out my problem. I can write out the literal manual analog steps that I as a human would do to solve the problem on a piece of paper, and it's like having a recipe next to your stove when you are cooking something. If I pseudocode that out, all I now have to do is take that and translate it into JavaScript. That's a lot easier than staring at a blank editor screen in VS Code and going, oh, I hope this works. That's a bad way to code. That's what we typically call cowboy coding, where you're just like six gunning from the hip. That was also my excuse to do finger guns. Yeah, try not to put yourself in the position where you're cowboy coding, and just use LSD. That's my. If you take nothing else from this lecture, it is use LSD. Cool. Any other questions? We're right at noon, so. Awesome. Crickets, tumbleweeds. I will take it. I will send out these notes and these examples and the output of everything I did on the console. And I'll also send you this so that you have it as a reference. But I promise every debugging scenario you get into, this will save your ass every time, 100% of the time. Ask yourself these three questions. Inevitably, one of them is going to be no. Inevitably, every single time. Cool. Thanks, folks. Yeah, sure.